As that action potential rolls down the axon, that depolarization, repolarization phase, it's going to branch out at the ends of the axons and get into the axon terminals. Now, at that axon terminal, there's that synaptic cleft or synapse, that gap between an axon terminal on the top of the screen and the dendrite down below. Now, as that axon terminal reaches, or as that action potential reaches the axon terminals, that's going to cause voltage gates for calcium to open up at the axon terminals. And calcium is going to end up rushing in to those axon terminals. And when calcium rushes in, what it causes to happen is it causes these synaptic vesicles, little bubbles that contain neurotransmitters, to start to move towards the membranes in that axon terminal. Now, when that synaptic vesicle reaches the membrane at the end of that axon terminal, it's like exocytosis. All of a sudden, those neurotransmitters that were in that vesicle, those little red spheres there, are going to be released into the synaptic cleft. Some of them will end up being eaten up by enzymes that clean up neurotransmitters in the cleft. Some will be retaken in, go through the process of reuptake and be recycled. Others will simply randomly diffuse across the cleft from a high concentration to a low concentration, and they may bind with their receptors on the membrane of the postsynaptic cell, which could be a muscle cell, a gland, or the dendrite of another neuron. Now, if those neurotransmitters bind with their receptors, it's going to cause a shape change, a conformation shift in those proteins, and some of them are going to be gates for sodium that will open up, and sodium will go from the synaptic cleft down into the dendrite, perhaps contributing to an action potential because we've got sodium entering a neuron membrane, and that may depolarize it, and we might hit threshold and have an action potential fire. Now, for other neurotransmitters, because some are inhibitory, they're going to bind with their receptors. And when these inhibitory neurotransmitters bind with their receptors, they're usually going to open up potassium-gated channels. And then potassium is going to flow along its concentration gradient and rush out of the dendrite or the postsynaptic cell, driving its membrane potential further down, making it harder for an action potential to fire. So that's what's going on at the synapses. It's calcium rushing in, neurotransmitters in little vesicles moving towards the membrane, and then those neurotransmitters diffusing across the cleft, attaching to the receptors, and either contributing to a depolarization that makes threshold more likely to happen and an action potential fires, or driving that membrane potential further away from threshold and making it less likely for an action potential to fire.